Today's lesson is modeling trigonometric functions. This is also known as harmonic motion. And what is my learning objective for today? I can model real-world applications using trigonometric functions by writing equations and solving for specific scenarios. Okay, so harmonic motion is motion that's periodic. So it's in cycles or cyclical is what we say. In real life situations that model harmonic motion are electricity, music, sound waves, light waves, tidal waves, weather pattern, and more. So the motion we describe can be modeled by a sinusoidal curve, which is either a sine wave or a cosine wave. One way I describe this is this is everything you can see and hear. Okay, so just as a quick review, for my general sinusoidal form, can you sketch what does a positive and negative sine and positive and negative cosine look like? So when we're sketching, we're just doing some quick lines. This isn't looking beautiful. I don't have to mark all these little boxes. So I'm just marking and sketching in 5 points. So for a positive sine wave, I start on the wave axis, go to a maximum, come down to the minimum, and end on the wave axis. So I should see 5 distinct points. A minus sign still starts on the sine wave, but this time I go to a minimum first, come back up to the maximum, and end on the sine wave. So I should see 5 points. Cosine starts at a maximum, comes down to a minimum, and ends on a maximum. These are the 5 distinguishing points. Cosine starts at a minimum, goes up to a maximum, and comes back down to a minimum. So these are my 5 points. And the 5 points are representing the 4 quadrants on the graph. Okay, so from 0 to 360. But when we're working in harmonic motion, we're talking about radians. So this is from 0 to 2 pi. So it's the unit circle divided into 4 equal parts. Okay, so let's do a tide problem first. Oops. Here. Okay, so something that's cyclical are tides. The graph indicates the depth of water off a certain pier in Port Aransas, Texas, beginning at noon on March 19th. Okay, A, what time and date is the first high tide? So I'm going to start out by kind of just sketching in and framing my sinusoidal curve. So here's my maximum. Here's my minimum. And I see that I'm going from -3 to +3, so my wave axis is the x-axis. So this is at y equals 0. Okay, so what date and time is the first high tide? So a high tide in the real world is referencing a maximum. So here's a maximum. And we said at time equals 0, it's March 19th at noon. So noon on March 19th. Okay, next question. What is the date and time of the second high tide? So the next high tide is right here, these are T, it says in hours. So if this is noon, so 12 hours later, this is going to be March 20th here. So it's 14 hours. T equals 14 hours. So this is going to be at 2 a.m. on March 20th. Next question. At what time and date is the first low tide? So low tide is asking me to find a minimum. So here's my minimum here. So this is at 7 hours. So this is at t equals 7 hours. So this is at 7 p.m. on March 19th. Okay, oops. All right. D, how long does the tide need to complete one cycle? So that is asking me what is the period. So one cycle is the period. So I know one cycle goes from peak to peak. So from here to here is the period. Okay, so this is going to be 14 minus 0 or 14 hours. Write an equation at time t in terms of sine. So at time t in terms of sine, so I need to start on the wave axis. So I'm going to start here. So this is my point here. So my C value here is from here to here is 3.5. So C equals 3.5. My B value, so B equals 2 pi divided by the period. And we said the period is 14, so B equals 2 pi divided by 14, which is pi over 7 when I simplify. My amplitude A is 3, so that's going to be from a minimum or a maximum to the wave axis. And my D value is what the wave axis is on. And since the wave axis is y equals 0, my D value is 0. So my A is 3, B is pi over 7, C is 3.5, and D is 0. So substituting into our equation. So since my C value goes to a minimum first, this is a negative sine wave. So this is going to be f of t equals negative 3 sine, my b is pi over 7, x minus 3.5, plus d, which is 0. So we usually don't write plus or minus 0. All right, let's write a equation in terms of cosine. So the closest location to the y-axis is the y-axis. So my c value is 0 there because I'm on the y-axis. I'm starting at a maximum, so this is a positive cosine curve. So f of t equals 3 cosine pi over 7 times x. I guess t. These are t. We're doing it in terms of t. I'm sorry. So we're talking about in terms of time. Okay, next question. These are the two questions that I give you the x value and ask you for y, and give you the y value and ask you for x. But I'm using t at this point. So what is the depth of the tide at midnight on March 19th? So the depth of the tide at midnight on March 19th. So that's here at my changing. So that's at t equals 12. So I need to make sure I am in radians. So my mode is radians. So I'm going to put in f at 12 equals 3 times, and I'm going to use the cosine equation. It is going to be pi over 7 times 12. And I get, rounding 4 decimal places, I'm going to get 1.8705 meters. So in real world, we have units. So make sure you're putting units. So, and I said mode is, we need to make sure we're in radians. And find the first time the depth of the tide is 1 meter. Okay, so where the depth of the tide is 1 meter is right here. So it happens more than once, but it's asking in this question here. So I have 2 lines and I'm going to find the intersection. So in the first equation, I'm going to leave my cosine curve. So in y1, I'm going to leave this as 3 cosine pi over 7. And I guess it's x in the calculator, so I'm going to write x here. And then I'm going to write the horizontal line, y equals 1. And I'm going to find the intersection. So my graph needs to look exactly like this. So I need to set my window to match exactly what my drawing looks like. And then I'm going to do intersection, second, trace, intersect. And I get t equals 2.743 hours. Okay, let's try another one. Here's a spring. So this kind of applies to people that are in physics, that have had physics or are in it now. So this is periodic motion. A weight is at rest, hanging from a spring. Then it is pulled down 6 centimeters and released. The weight oscillates up and down, completing 1 cycle every 3 seconds. So I'm visualizing what this looks like. So this is the weight sitting here. So it says it pulled it down. So I want to know, am I starting at a maximum, the wave axis, or a minimum? So we're sketching in here. And when I'm thinking about this, oops. I'm pulling it says the weight down. So I'm starting at a minimum. So I know this is what my shape looks like because I got periodic motion going on here. So here I know we're talking in seconds. So this is time in seconds. And this is going to be my height in centimeters. Okay, and it said that I pulled it down 6 centimeters. So this is minus 6. This is plus 6. So here's my maximum. Here's my minimum. Let's see. What did it say? How long? It oscillates up and down, completing 1 cycle every 3 seconds. So I know 1 cycle takes 3 seconds. So this is going to be 3 seconds. Okay. So I want to write an equation. Am I going to write a sine or a cosine wave? So I am looking at C is at starting on a minimum. So I'm going to be writing a minus cosine wave. So at point A, my C is 0 because I'm on the y-axis. So f of t equals my amplitude is 6. My period is 3. So b equals 2 pi divided by, b is 2 pi divided by 3. Here my c value is 0. And the middle of my wave is the x-axis. So y equals 0, so my d value equals 0. So substituting into my equation, I'm doing a minus cosine curve. So minus 6 cosine 2 pi over 3 times t, because c and d are both 0. What is the position of the weight at 1.5 seconds? So 1.5 seconds is halfway. So this is going to be here. So C is 1.5. So I can either do this F at 1.5 equals negative 6 cosine 2 pi over 3 times 1.5. And putting this in my calculator, I should get 6. Or I should realize I'm at the maximum, which is 6. And these are centimeters. Use the graph to find the time when y equals 3.5 the first time. So 3.5. The first time, so it's talking about this spot here. So for point C, I am trying to find what is that value. So I want to know what is t here. So I'm going to find the intersection of those two lines. So I'm going to have in y1, I have the minus 6 cosine 2 pi over 3 times t. And in y2, I have 3.5. So I need to adjust my windows so I see exactly this, and I'm going to find the intersection. So I get t equals 1.047 seconds. My last question is, what does y equals 3.5 represent? And 3.5 is 3.5 centimeters above resting. Okay, so if I have a word problem that doesn't show me a complete graph, I have 4 equal parts. So depending on which fourth of the graph I have, I can still write my equation. So let's just review a couple simple things here. Okay, let's just do a quick review here. So when I have my equation, my general equation is f of x equals a times the sine b of x minus c plus d. Okay, so this can be sine or cosine. Okay, the equation of the graph is determined by what I choose as the c, the phase shift, whether it's a sine or a cosine, and whether it's positive or negative. I want to solve for all the parameters. So I need A, B, C, and D. And I have 5 points. These 5 points represent 0, 90, 180, 270, and 360. Or in radians, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Because I am dividing the unit circle into 4 equal parts. Okay, so if I don't have the whole graph, I can still figure out the period. I mean, I have this circle in fourths. So if I have 3 points, how much of the circle do I have, the unit circle? So I have a lot of students that say, I'm a visual learner, and wait for someone else to draw the picture. So you need to draw the picture. Someone else isn't going to draw the visuals for you. Okay, so if I have 3 key points, that would be these 3 points. So when I have 3 points, I have half of the circle. If I have 4 key points, how much of the circle do I have? So 1, 2, 3, 4. I have 3/4 of the circle. If I have 2 key points, I have the first 2. I have 1/4 of the circle. So if I don't have all 5 points, I still know how much of the unit circle I have. So when I have a portion of the graph, to find the period for if I have half of the graph, then I need to multiply times 2. And if I have 1/4 of the graph, I know I need to multiply times 4. So if you don't have the full graph, then understand how much of the graph you have and multiply it by the appropriate amount to find the period.